Great. So, ultimately, just like the control, we're using a lot of this visibility and telemetry inside the Nile service block to ensure that we're giving those guaranteed, outcomes or those predictable outcomes as it relates to the performance capability of the network. But, while we give you the control to be able to configure the services, we also need to give you the visibility you need to support your users and devices effectively. Part of that starts with users being able to do some level of self-service. I mentioned before that there's going to be an interactive demo portion of this. If you guys want, you can go right now to my.nilesecure.com. You're going to have your own user self-service portal that's going to help you diagnose your own connectivity issues in a user-friendly way to kind of fill that gap between when users first encounter an issue to the point where they get frustrated enough to call the help desk and then give some generic problem statement like the network's slow, the network's broken, or something even worse. Right? You guys can take a look at that. We'll dig into that, but that's an integral part of trying to minimize the impact of quote unquote network related issues that might not even be in the network and dramatically reduce the mean time to resolution for the issues that actually exist. The second piece of that is the IT experience, giving the IT folks within the organization proactive visibility into where the problem is so they don't spend a lot of time where the problem isn't, as well as giving reactive capabilities so when the user does call the help desk or open a help desk ticket, and we'll show you that, they can quickly, within one click, figure out exactly where the problem is and how to resolve it. So let's walk through that from a demo perspective. So if we click in, we're back on our dashboard. We can actually see the SLAs provided by the network, us giving that guaranteed performance. We're doing all this cool stuff behind the scenes that Suresh and Pramod have talked about with regards to the instrumentation, telemetry, the data-driven decisions, all the software upgrades, and how we kind of roll this stuff out to give that guaranteed performance around availability, coverage, capacity, that we have financial penalties if we don't meet these for customers. We take care of all that burden to deliver that type of outcome. Now, if the network is problem-free, if the network is innocent, and if that tab shows that, that means the network is innocent. And we even go as far to say, because this is a service, even from a user perspective, and for those of you, I think there's a camera pointed to it, but we have an AP up in the background, in the back of the room that's up on the service right now. We've gone as far even to show from a user perspective, that LED on the AP is a service indicator. Is the service up from a holistic perspective, or is the service a problem? From a user's perspective, is the network up? Or is the network a problem? And that LED showing green means the service as a whole is providing this type of guaranteed performance to the environment that customer's in, or those users are in.
So that green is not just meaning that AP is up, it means it can all the way communicate up to the cloud? Is that what?
That's correct.
Okay, and all the services, all the clients that it's capable to serve all the clients, and those clients will be able to connect wherever they need to connect.
As it relates to the Nile network block itself. Now there's other elements, right that we're not controlling. Things like the internet connectivity, things like radius, things like DHCP, things like DNS, the Wi-Fi noise. Could even be, to Suresh's example before, the application might be Facebook, right? So we're not that's not showing green guarantee, but the piece that we control, that's
right. Like, I mean, as a client, I can connect to it, I'll get an IP address. Now, because of interference, that's a separate issue that will probably show up in there. I'm zooming in the dashboard or something like that. And then if there's some other issue with WAN or something like that, that's in there. Okay.
Exactly. So it gives them that assurance at least, and that's a simple example of the big shift from going to a product-centric approach to a service-centric approach. It's not the matter of is the AP up or is the switch up, but is the service providing this level of performance?
Are there different LED codes also?
What's that?
Are there different LED codes also? Like
there's a green and a red.
Okay.
There's actually a blue as well for provisioning, but there's no Morse code kind of secret decoder ring to kind of decode, this problem versus this problem versus this problem, right? So let's say the network's up, the network's good. Now it's providing the service with the guarantees that we talk about. We know that when a user calls in a problem, to Suresh's point earlier, they're going to say in a frustrated way, the network's broken. Right? And they're not going to give a lot of information to the poor help desk person to get them to figure out where do I start with this generic frustrated problem statement. We want to try to solve that before that happens. So all these synthetic tests that we do, when you configure the network to kind of tell us what your DHCP servers are, your radius servers are, what have you, we start automatically configuring and running synthetic tests. These are relatively simple tests. We're not full application performance monitoring. This is trying to give an indicator of is a service available and what is the experience that service is providing to the end users. Just to give an indicator as to, is it good or not good? And if it's not good, you should probably use your other tools or other systems to go diagnose what's actually going on with that particular service or application. So we're doing that for DHCP, DNS, internet, and radius. We're also doing it for the applications. And Suresh mentioned before with the applications, and again, it's a relatively simple test. It's an HTTP ping for all intents and purposes, checking availability and experience. But today, we start off with putting the top 10 internet applications up there. Customers, as Suresh pointed out, can tell us, hey, we want these applications up there, and we can do that behind the scenes to make sure that's going. But since we are the network infrastructure, we're on a path relatively shortly to get to a point, since we know, and this gets back to a question that was asked earlier, since we know what applications essentially the users are using, and we can see what the top ones are by bandwidth, by number of users, by number of sessions, we're going to have the ability soon to automatically tune this list to the top applications that are in use in that environment and start running those proactive tests against that, so you know the applications that the users care about, what's the state of them, right?
A little bit back up. I have a question from Mark, and he's asking about the DCP, cloud DCP, right? Like latency, or what if the cloud is unavailable? I'm assuming that cloud DCP, I mean, that config is not actually getting pushed out to a device itself, right? It's strictly in the cloud, correct?
Sure,
Okay.
that's right, because it's a cloud. So if you really look at today end users, without the internet connectivity, they cannot really do anything much anyway. That's one, all right? And second is, most of the devices that are already in the network, they try to renew it halfway through their lease period. So usually they don't have any problem. Any device that's already in the network will continue to work even if the DHCP server is down. And third is, if we do realize there are some customers who want complete, local availability, in those cases, we interoperate with your existing DHCP services if you want to.
So like a backup DHCP or something?
Yeah, if you want to, we could.
Is there like a specific number, like, hey, DHCP latency needs to be like below this number or something?
Sure.
Like that?
So this is, again, we have many customers who are already using it. Frankly, it has not been an issue. So we're going to be publishing our SLS, if you talk about it, availability and the latency and performance, we're going to do that.
But taking that back to a customer's DHCP server, a customer's applications like Radius or applications that we might be monitoring, the latency comes into play too, because typically when you're setting up systems like this to monitor these applications and services, you have to define a threshold. And what is a good threshold versus what is a bad threshold? We're going in and baselining good, and then we're going to evaluate that against what's actually being seen to determine, is that service providing likely a bad experience to the users? For example, here, maybe we have users complaining about applications that are, or workloads that are hosted on Google Cloud Platform. We're running these synthetic tests, and we'll give you, hey, in this time spot, it's good, but at this point, there likely was a bad experience because the round trip time, the latency shot up dramatically. Users probably felt that, right? And if users called in trouble tickets at that moment in time, you have that level of couple click visibility to see that that likely was the cause, right? Again, not solving it at this point, but directing your few IT resource to the area where the problem is versus where the problem isn't. Now, let's say, coming back to this, all of this is green. Network's good, applications good, services are good, but users are still perceiving some type of issue. Let's say, for example, they might fat finger a pre-shared key on an SSID. That happens all the time. Since we're the network infrastructure, things like that will pop up right away on here to show you that, hey, somebody might have fat fingered a pre-shared key. That's what caused that user issue at that moment in time. Maybe they failed Radius authentication. Maybe they failed SSO authentication. Maybe the DHCP scope ran out of IP addresses. That level of visibility is in here. Now, if that's not even indicating any user issues, but users are still perceiving a problem, this is where I asked you guys to interact with our self-service demo in the live environment, where you can go to mynilesecure.com. Every user that's connected to a Nile network has an access to their own self-service portal to try to give in a non-techie type of way some indication of what the connectivity looks like. You've got video grade signal, right? The internet is up and it's good. You could even dig into your applications if you want to see how those applications are likely running. And if Facebook is down, it'll tell you right away if Facebook is down. You could even run a speed test if you wanted to. Now, if none of this is indicating what the issue might be to give you some level of assurance that, hey, just wait, it'll go away, you could even open a help desk ticket to give that help desk person all the nerd information they need to start troubleshooting this. Instead of them asking you what's a MAC address, what's an IP address, can you open up a command prompt, can you do a trace route, can you do a ping? That goes away. From this portal, they can click, put in some relevant information, take a screenshot of this portal, send it off right to the help desk, and then the help desk goes into ServiceNow or whatever their ticketing system is, sort it. You can see the issue. GCP is slow, in this user's particular situation. Click on it. The help desk now knows, here's the information I need to start. They jump into the Nile portal, and from a reactive perspective now, hopefully within 1 or 2 clicks, we can expose what that issue is. So they can come in here into our client detail page where you can actually see all the users, MAC addresses, IP address, where they're located, how they're connected, fingerprint, all the information you need. Find the user by IP address, by username. I just found myself on here. Go in, and actually you have within this one page, the client detail page, a lot of information. How the host is connected, where it's connected, the type of capabilities it associated to on the SSID, event information as it relates to the association, DHCP, authentication, all the layer 1 stats that you could ever want as it relates to signal, noise ratio, retry rates, etc. And if you scroll further down, you can actually get the location information on the heat map. By the way, remember when the first step, all you did was upload a floor plan? The result after our installers are done installing this is you get accurate location information and heat maps. Nobody has to do anything extra to get that. You get a roaming history. You even get visibility into the services, the multicast discovery services like AirPlay and all that other stuff that the host might be supporting and using. If none of this points out the problem, we then want the capability to have the IT admin run a bunch of tests at this moment in time to figure out, is it a layer 1 problem? Is it a layer 7 problem? Is it a network service problem at this moment in time? They can click this run test, and this run test kicks off 21 different tests from layer 1 to layer 7 to try to expose what the problem is. If this still doesn't expose it, and I need some information from that user because they're complaining about something, again, I want to minimize that user frustration. We deploy these physical sensors that plug into the wall outlets all around the environment. We've talked about it multiple times today. Another added capability of those sensors is the IT admin, while they're in this client detail page, while they're in this run test function, can say, hey, I really want this user to run a ping or a trace route or whatever, or run a speed test, but they're frustrated. I don't want to ask them to open up a command prompt. I can click run test from, for example, just trace route. The system picks the closest sensor to that user, so I can run this test in their environment and reports back the results right there. Done. So hopefully at some point, something exposed where the problem is so we can effectively troubleshoot the user to bring down that mean time to detection of what the issues are and the mean time to resolution of the issues that fall on my plate.
So that's on the wireless side. What about on the wired side, right? If the cable's bad or, I don't know,
Yep.
bad nick or something like that, and that's causing and dropping just something on the
You're going
wire.
to see relevant stats about port flapping, CRC errors, negotiated rates, all those types of things in there.
Okay. One more question. So let's say I don't have too much of cloud-based apps that I'm using, right? I have a data center. My connectivity, go to the data center. I have a bunch of servers there. All the applications right over there. My users need to access those applications locally to the data center. I lose, let's say, internet access. Now I do not have at all connectivity outside, right? But will I still be able to access my users, all the applications on the local servers, like to my data center, or that?
The Nile service block does not go down.
Okay.
If we lose cloud connectivity. Now, you're going to lose visibility that I just showed you in the portal for that period of time.
Right.
And you're going to lose any level of additional control that you want to do on the network. But any users that are currently connected, as well as any services that are currently configured, like Radius, all those new authentications against Radius and everything else will still continue to work.
Okay.
Yep.
Gotcha. But just new associations will not happen though, however?
No, they'll continue to work.
Yep.
They'll continue to work because it's not dependent on the cloud at all.
Okay.
Okay.